Hello, everybody. My name's Aditya.
I'm Daryl.
I'm Matthew.
I'm Rohit.
I'm Zechen.
And we are CSE Senior Design Team 16. Let's dive into our project.
For our project sponsored by Sonalists, we were tasked with designing, prototyping, and developing an AR application that interacts with static exhibits and overlays interactive three-dimensional models over them. The motivation behind this project is to expand on the existing uses of AR to incorporate more educational-based elements and teach people both visually and orally how various static exhibits, such as those that exist within museums or open spaces like a college campus, look like, operate, and function. Our project is an augmented reality mobile application that is able to render animated 3D models in real time and geospatially anchor them onto tags within the real world. It is capable of image and object recognition, can support an AR view that contains spatial awareness, and provide a secure user authentication service while having a friendly and interactive UI.
There were several criteria that our team considered when choosing a solution. First and foremost, we needed a front-end development tool that would provide robust AR functionality for us to make use of. Given that we were making a mobile application, we narrowed it down to a few options which best supported that: the Unity game engine, React Native, and ARKit in Android Studio. The team decided early on that a back-end service would be implemented, and the primary options that we discussed were Firebase and AWS. Aside from the actual technical concerns of these options, there were a few other considerations that the team had. We wanted a solution that we had some experience with going in, and that had plenty of documentation and support available to tackle any challenges that came up during the development process. Additionally, because this project had no associated budget, any development tools that had no cost to use were highly sought after. With all these factors in mind, we chose to utilize Unity with a backend consisting of Firebase and Google Cloud Storage.
Now let's dive into our solution. The front end of this application is being developed in Unity 3D. It's a cross-platform game engine that provides a developed environment to create interactive 3D applications and AR applications as well. Inside Unity, we utilize the AR Foundation library to carry out AR features like image recognition, object detection, and an AR viewport that contains spatial awareness and AR sessions. We also use the adjustable system, which is an easier way to enable us to import assets such as 3D models from remote cloud locations. In addition to this, we are using Blender to create our 3D models and holograms that we will use in our application. Blender is an open-source 3D computer graphics software that will allow us to model intricate details, add animations, and create textures for our models. For our backend service, our Unity application is integrated with Firebase and Google Cloud Platform. Through Firebase, we are able to implement the secure user authentication and login, and adding NoSQL database connection for storing user and AR metadata. With GCP, we use cloud storage to remotely store 3D models.
When we launch our app, the user is prompted with a login form, which is backed by Google authentication services. After successfully logging in, the user is brought to the welcome page. On this page, we see a few different options. Choose a location, enter AR, and My Profile. My Profile shows where the user's information would go, and clicking on the Locations drop-down menu shows the different options available. Once the user selects a location, they can enter the AR viewport. Based on what location was selected, corresponding 3D models that exist in that location have been fetched from the cloud and loaded into our AR scene.
In the demonstration, I approached the Jonathan the Husky statue and scanned in the associated tag placed next to the structure in my AR scene. Instantly, the tag is registered by our image tracking system, and the appropriate 3D model of Jonathan is spawned in and anchored onto the tag. The application also fetches the respective model data from our Firebase database and renders this information into an AR UI panel for the user to read. This panel can also be closed and reopened as per the user's liking.
The sundial was modeled in Blender by a combination of various cubes and shapes. It has a spinning animation as well. We managed to make the base look granite in color by applying a granite picture texture to it. You can also see a real-time shadow rendering on the sundial onto its granite base. The prism was the first model that we created. It also has a spinning animation that is limited to the top part of the model. In order to only have this top part move, we had to add an armature, think like bones, to the model, and then only rotate the upper bone.